Good morning, dear students. Today we'll begin the class on the topic colloids. I think I have already posted the material. Now, before going into the chapter, we'll see some of the examples of colloidal systems that we come across in our daily life. Most of the food that we consume are based on colloids. Some examples are milk, curd, butter, cheese, cake, bread, etc. Many of the stabilizing agents like gelatin added in ice creams is also an example for a colloid. A number of medicines that we use are in the form of colloids for their easy and effective absorption and assimilation by the body. Several of the antacids, antiseptic lotions, cough syrups, ophthalmic lotions are also colloidal in nature. Now, we'll move to the introduction part. Thomas Graham, regarded as the father of colloidal chemistry, was the first scientist to discover the distinction between the two substances and classify them as colloids or crystalloids. He developed a system of classification based upon the size of the particles. During his investigations on the diffusion of solutions of different substances through a parchment membrane, Thomas Graham observed that the solutions of sugar, salts, etc. diffused readily through the membrane, while those of gelatin, glue, etc. diffused only at a very slow rate. The substances which diffused readily were called as crystalloids, where they show crystalline nature, and those which diffused only slowly, generally found in the amorphous form, were called colloids, meaning glue-like. However, later he realized that the above categorization is not rigid and it depends upon the conditions. For example, an aqueous dispersion of soap shows colloidal behavior, whereas its alcoholic solution exhibits crystalloidal behavior. So the term colloidal substance is not used nowadays to describe any particular substance. In fact, any substance can be brought into a colloidal state by suitable means. Let's see the distinction between a true solution, a suspension, and a colloidal solution. What is a true solution? A true solution, for example, sugar in water or sodium chloride in water, is a homogeneous system where the solute particles have their diameter in the range of 0.1 to 1 nanometer, which means they are not visible to our naked eye or even under the most powerful microscope. But they diffuse rapidly and they do not settle down on long standing. Hence, they cannot be retained on a filter paper. Whereas in the case of a suspension, example sand and water, it is a heterogeneous system where the particle size is greater than 1000 nanometer. Obviously, it is visible to our naked eye and they do not show any observable diffusion because of their larger size. Hence, they settle down rapidly under gravity and they can be easily retained on a filter paper. But in the case of a colloidal solution, example starch dispersion in water, it is a heterogeneous system with particle size in the range of 1 to 1000 nanometer. They are not visible in any microscope and they show lower rates of diffusion. They do not settle down and no, they can be retained on an ordinary filter paper. So the colloidal solution comes in between these two extremes of true solutions and suspensions. So the essential difference between these three systems is in their relative particle size. Also, there is no sharp and rigid dividing lines separating these three. Instead, there is only a gradual transition from one system to the other. Or in other words, we can say that many of the characteristics of these systems shade into each other without any discontinuity. Now we'll see the definition of a colloidal solution. A heterogeneous system consisting of two phases, the dispersed phase with the colloidal particles and the dispersion medium with the solvent in which these colloidal particles are dispersed. Next is the type of colloidal system, the classification based on the dispersed phase and dispersion medium. Now, if the dispersed phase is a solid and dispersion medium is also a solid, we call that colloidal system as a solid sol. Examples are colored gems, stones, colored glass, etc. Now, if the dispersed phase is a solid and the dispersion medium is a liquid, we call such system generally as a sol. Example, dispersions of starch, paints, etc. Now, if the dispersed phase is a solid and dispersion medium is a gas, we call it as a solid aerosol. Examples are smoke, dust, etc. Now, if the dispersed phase is a liquid and solid is a dispersion medium, we call such system generally as gel. Examples are jellies, cheese, etc. Now, if both are liquids, like the dispersion medium as well as the dispersed phase are liquids, we call them as emulsions. Milk, oil, etc. comes under this. Now, if liquid is the dispersed phase and gas is the dispersion medium, we call it as a liquid aerosol, which includes mist, fog, etc. Now, the dispersed phase is a gas and solid is the dispersion medium. We call it as a solid form. Rubber, cake are examples for this. If gas is the dispersed phase and liquid is the dispersion medium, we call that colloidal system as form. Soap form is a